Hello, in this video we're going to derive a backward bending labor supply function from a perfect complements utility function. A worker's utility is given by the following. C is a consumption good priced at P. L is hours of leisure. The worker's wage is W. We're going to solve for the worker's labor supply. That is, we're going to solve for hours of work as a function of the wage and the price of the consumption good. We're going to assume that there are 24 hours in the day that can be split between working and leisure. So 24 equals H plus L, and we could solve this for H. H equals 24 minus hours of leisure. Let's first form the budget constraint. It'll take this form, PC equals WH. The left-hand side is the amount of money that can be spent on consumption, the price of consumption times the units of consumption. And that's going to equal the wage times hours of work. Where H here is 24 minus L, so I make a substitution into the budget constraint. So again, our utility function, our budget constraint. And now to maximize utility, given this functional form, it must be true that C will equal L. And what we're going to do now is we're going to substitute L for C in the budget constraint. So we have a C, since C equals L, we're going to replace that C with L. So making that substitution and solving now for L. Factoring out an L on the left-hand side and dividing through by P plus W. This is hours of leisure. Since hours of work is 24 minus L, we're going to have 24 minus our following result over here. Getting a common like denominator. And simplifying, we have our labor supply. Hours of work here is a function of P and W. We'll note that this is going to be backward bending. As W increases, the denominator gets bigger, so hours of work gets smaller. Or taking the partial derivative of the hours of work function with respect to W, we get a result that is negative, less than 0. Okay, I'll stop here.